let's look at what we call, it's a photodiode. The photodiode, it's this type of a setup where we doing the photoelectric effect. We're incidenting the light that is going to come here to this metal, right? This metal, it's a sodium. We can change it there, the metal, using any metal, but this one is going to be a sodium. So this is the metal where we're going to shine light there. And then this one is a cathode, right? And this one is a what? Is an anode. So what we're going to do here, we are going to shine a light of different frequencies and intensity there, and we have an ammeter there. The ammeter there, it shows us the current, which is the flow of the electrons that are ejected here. It will be the current, right? And then we're going to alter the intensity and the wavelength. So when we change the wavelength there, that means we are changing the energy, we are changing the frequency, right? The bigger the wavelength, the smaller the energy, the smaller the frequency. So when we change the intensity here, the intensity of light, which means we are changing the brightness, we are changing the number of photons, and that means we will changing the number of electrons, photoelectrons emitted per unit time. Now let's do it. Okay, let's do this. Now we have different metals here. We're going to use the sodium, and then we're going to switch it on there. So those waves that you see there, those waves that are there, those are the photons there. So when they hit the metal, there's a photoelectric effect that occurs. So what I'm going to do, I'm going to increase the intensity. If you're looking here, I'm changing the intensity. You see, when I increase the intensity, do you see the number of photons, which is these photons, they increase. So when I increase the photons there, power on, when I increase the photons, look, when the intensity is like that, do you see the photons? And the photoelectric effect occurs, which is these electrons are ejected there, right? But what you need to look at, when I increase the intensity, there will be an increase in number of photons, and there will be increase in current as well. Look at the current in the ammeter. So when I increase, do you see the number of photon increases, the current increases? That means the intensity or the brightness of light is directly proportional to the what? To the current, and is also directly proportional to the number of photons, right? Which is the current, it's the number of electrons ejected per unit time. Now let's change the wavelength now, which is when we change the wavelength, we are changing the energy and the frequency. So do you see, that's the higher, look at the graph, that's the higher wavelength, a smaller wavelength, and then let's increase the wavelength. Do you see, when we increase the wavelength, look at what is happening to the current. The current decreases because increasing the wavelength, we're decreasing in energy. Do you see? So decreasing in energy, do you see, even the current is 0. Now when we increase when we decrease the wavelength, that means we are increasing the energy. That means that there, look at the number of photons. The photons are the same, but what is happening there is the kinetic energy. They are faster, right? Do you see, the kinetic energy is still the same, it does not change. Look at the graph, it does not change. But when I change the wavelength, which is I'm changing the energy, look at the kinetic energy graphically. Do you see? graphically, the kinetic energy increases, even the current increases. Let's look at the graph of the current versus intensity. So now I'm changing the intensity. Let's look at the current versus intensity. Do you see the graph? It's a direct proportionality graph, increasing the intensity, increasing the current, but the kinetic energy is going to be what? The same. But let's look at the intensity, the graph of the intensity and the current when I increase the energy. Do you see? The intensity remains the same. What is changing is the what? Is the current, right? I hope that makes sense, guys. Let's look at the relationship between the frequency of the light and the number of electrons, of photoelectrons, and the kinetic energy. And we're also going to look at the intensity of the light and the number of electrons per unit ejected per unit time, and the kinetic energy. Now, suppose that the photoelectric effect has taken place, right, which is the energy that of the light is greater than the work function. So here the photoelectric effect has taken place here. But now if you look here are the photoelectrons, and these are photons. This is the incident light with the photons, right? Now what will happen to this scenario, as you've seen in the previous simulation? What will happen if you increase the frequency of light? So when you increase the frequency of light, that means you are using a different light, which is a different light of different energy. So increasing the frequency therefore increases the energy of photons. Now look at the photons. The photons here were this size, but look at, they are big, which means you are increasing the what? The energy of photons. Look at the number of photoelectrons. The photoelectrons are still the same, but what happened, the electrons now, they have a greater kinetic energy. They have more because you increase the energy. When you increase the frequency, you're increasing the energy. That means there's more energy in excess. That excess energy is going to be converted into the kinetic energy. And if you look at the number of electrons the number of electrons ejected, there will be what? There will be more number of electrons ejected per unit time, right? There will be more, there will be faster. Since there will be faster, there will be more electrons ejected per unit time. So here the current, the kinetic energy increases, and the current, which is the number of electrons ejected per unit time, is the current, it also increases. Now let's look in the scenario where we increase the intensity. So when we talk about the intensity, we talk about the brightness, right? The brightness, and the brightness is the power of the light, right? So when we increase the intensity of the light, we increase the number of photons. Very important. The number of photons increases. Look at the photons that we had, and look at the photons that we had. Now when we increase the photons, that means the number of electrons ejected per unit time, the number of electrons ejected per unit time, which is more electrons, more photoelectrons emitted per unit time, are stronger, which is the current. There's more current. Do you see? There are more, and the kinetic energy remains the same. So here, when you increase the brightness, the current increases, the kinetic energy remains what? The same, right? It remains the same. It's very important. When the photoelectric effect already taken place, the current can therefore be increased with an intensity, with an increase in intensity, which is the brightness. In the formula that says Q divide by T, which is the time, the current is equal to the number of photoelectrons. So this is the current and the electrons over time, right? If the photoelectron are already taken place, the increase in frequency of light increases the what? The current. all the time. When you increase the frequency, the current will increase. The strength of the current, it depends on the rate in which the photoelectrons emitted. This is very important, guys.